break. That's great. Okay, so we had given a square root function, for example, talked about that. And we had actually taken a glimpse at some examples, just one example up front, that serves as one representative of the class that we're looking at today. So suppose we have a function whose job it is what? It's supposed to compute factorial. That's the what it's supposed to do. What is this program supposed to do? What's its contract supposed to be? What's its job in life supposed to be? That given a number, n, as an argument, formal parameter of it, it will compute the factorial of that number. Now, there's some code that supposedly implements that contract, supposedly delivers on that contract, supposedly it fulfills that contract. And we're going to be looking at this code and trying to assess, does it deliver on that contract, and if not, what can we do to improve it? Okay, so here we have a bit of code. So as a sort of general programming idiom perspective, ladies and gentlemen, what's missing from this code? There's something big missing. And I invite you to look at its contract. You go look the name, the signature here, so-called the signature, what it takes as an argument, what it gives back as a return value. It tells you something about what its job is. Often the name gives you some hint. We should really have some further description saying what this does, and what its legal inputs are and so on. But here you're presented with a case you'll often see in practice. So given the signature and so on, given its job in life, what's being missing? Yeah, where's the return value? Right? No return value. So that's a good place to start. For it to live up to its job, we need, ladies and gentlemen, a return value. Okay, so now let's start thinking about boundary conditions. Okay, so suppose we had a return value. What are some boundary conditions for this? Okay, yeah, so, well, okay, maybe I should first ask. I don't actually like, what are the equivalence classes here? What are sort of broad classes of inputs we'd expect it to do sort of similar things, for which we'd expect it to do similar things? Okay, reasonably large positive things, yeah, good. Okay, negative things would be another class that it should deal with in some way. And any other classes? Okay, things that are positive or negative, good. Good. Anything else? Okay, one would be an interesting case, yeah. So there are these, there's a fixed point of the factorial operator. The factorial one is speak, use, 1. Yes, so that would be another interesting case. Any others in mind? Pretty good set there. Okay, excellent. So we have these little classes. Okay, so what would be some boundary things you might want to, so we might test at least one number from each of those. What will be some ones that are either part of this or boundaries that you want to test it with? Well, one that I heard earlier, it could be viewed as a boundary, but it could be viewed as its own sort of input, is for 0. Another one would be for 1. Okay, so what happens if we give this thing 0? We give this 0. I hear the C interpreter running in some heads. Okay, so if we give it 0, we have back equals 1. Does this while loop get exercised at all? No, so it returns. Is that correct? Yes. Yes, by definition, 0 factorial is equal to 1. That's just part of how it's defined. Okay, so how about for n equals 1? If we have n equals 1, we come down to 0. And is this loop exercised? And what happens when it gets exercised? Back is 1 going into it, and then it multiplies back times 0 because n has been decremented here. and we get fact equals 0, and then we go up. Is it exercised again, the loop? Does the loop go a second time? No, falls through. We return fact equal what? Is that correct? Is 1 factorial should be 1, but it's actually showing 0. Okay, so there's a problem. There's a problem there. And we could have run it. Okay, so suppose we were to fix it. You can imagine, by the way, having that test written that, fact of 1 should be 1, and it runs and it fails. So you go and you modify it this way. Okay. So does that fix that problem? Well, it turns out it fixes that problem. But how about another boundary? How about another? This is a boundary case at the boundary. We'd like it to be one that's handled as it should for all negative values. But right now, are negative values handled here at all? Okay, so if we give it n equals -1, what happens? Okay, so it's going to fall through here, fact equals 1. Okay, is this loop going to be exercised? Yes. And thence begins the vicious cycle. Thence begins the vortex of death, the maelstrom of infinite loops. Okay, so it actually exercises it, and then it'll multiply back times -1, okay, which would be -1, and then it'll be decremented by 1, which is -2, and then what will happen again? With grim progression. It'll just loop and loop and loop. It'll become ever smaller, and it's computing, but it's computing nonsense, ladies and gentlemen. Full of sound and fury, signifying nothing. Okay, so we can put something in here like this. Okay, if n is less than 0, return 0. Otherwise, do this. So now we've kind of defined factorial for negative numbers to be 0. Now we'll talk about other mechanisms for doing this sort of thing more robustly. Everyone, I think in here, just about everyone's taking 270 right now. They talked about exceptions, throwing exceptions. So this would be a good case where, depending on the contract involved, you can define a factorial contract to say, if it's given a negative number, it'll throw an exception. Alternatively, you could define it so it returns 0 for all negative numbers. That would be part of the contract of it. You could simply say, we will not take in the behavior is undefined for numbers for n less than 0 and have it to return 0. So this is one way of implementing that. That is less than 0, return 0. So what else could be improved? First of all, does that fix that issue? Yes, but we could improve it by having a clear else here. It makes it just clear, okay, this latter case is handled if this first case isn't. Okay, and to kind of make it more, to make it cleaner yet, we might want to balance these parentheses. This is a matter of style, and I don't have a strong feeling about it, but many people believe that if you look at these curly brackets, it's kind of nice if they line up vertically. Here, these two are sort of lining up, but to figure out that they're balanced, you got to kind of look horizontally and vertically. Some people prefer it this way, and some coding conventions will use that. Okay. Okay. So here we have factorial. Suppose we were to give this a large number, like n equals 1,000. What's going to happen? Are we going to get back a meaningful number out of this? Sorry? Not even slightly, that's right. It'll be so absurdly large, so so quickly, in fact, that you'll quickly exhaust the ability to compute with n's. And you'll get back a number, sure enough, but the number will be meaningless. The number won't really mean. So this function has a lower bound under which it gives meaningful results, 0. It also has an upper bound, and really we should specify that in a contract. And we're going to be getting to contracts in a later lecture. I'm not going to go into it here, but we should make it clear to the user that if you give this thing 1,000, you're going to get back nonsense. You're not going to get back a meaningful number. Okay, so let's. So that was a factorial example. Let me stop that.